Hello and welcome. After giving you an overview over space infrared telescopes in the last presentation, I will start now to make videos about ground-based and air-based infrared telescopes. And the first observatory I'm going to discuss is the Eastern Anatolia telescope. See now these two pictures here. The left top one is still where it's still being constructed, and the right one is actually simulation, how it should look in the end, although it's finished now. These presentations are always going to have the same structure. First, history and purpose or motivation to build the observatory, then the equipment it has, geography, and also a little bit what it means about the weather. Then some notable results, if there already are any, and a short summary. This observatory belongs to Atatürk University in Erzurum, Turkey, and it had its first light in 2024, but testing went on in 2025. So now we have 2026. I don't know if it's in regular service already. They took 5 years to look for the best place in the Karakaya Hills. The people realized that these hills, actually there are mountains, they're very high. We'll see that on the next slide. And these mountains, it was clear from the start that these mountains could be a very good place for infrared astronomy because it's very dry there. And it's also very practical because it's just 10 kilometers from the university, and there isn't an asphalted road going up there, but there is a cable cart from a ski resort. It will be able to measure in visual and in near infrared. I would call it shortwave infrared, going up to 3 microns. And they want to do in international projects and collaborative studies. The main aims are direct imaging of exoplanets with coronagraphy, measure stellar spectra of stellar environments and also spectra of galaxies, look at galaxy development, and also do stellar statistics. And this is what the telescope looks like. It is a 4 meters Ritchey-Chretien telescope with a 0.76 meter secondary and a Nasmyth focus. And it has active and adaptive optics and an f of 56 meters. So it's good to measure single objects or small objects. And it has been built, the optics has been built by Amos in Belgium and the mechanics by EIE from Italy as a subcontractor. What is active and adaptive optics? Adaptive optics basically means that the main mirror is thin and sits on a computer-steered model that is optimized for the view that you're just looking at. Whereas active optics often works with thin mirrors somewhere downstream that are able to make the images a lot sharper and have to react in milliseconds to the flickering done by the air. So normally you have both in a telescope, in a modern telescope, but they're not strictly the same, active and adaptive optics. But often when you start computer optimizing, you do both. And what is a Nasmyth focus? Here in the back, in front of the main mirror, primary mirror, you can see a Newton-like flat mirror that just projects the image outside. So you can have the detectors, maybe an imaging camera here and a spectrograph here, and you just have to turn this little mirror and then you can choose which instruments are gonna work on the image. That's also a big advantage of ground-based telescopes. If your instruments get older and there are better ones, you can just swap them out, which is difficult or impossible in space telescopes, although it has been done in the Hubble telescope several times. Then about the geography, here is the place in the main part of Turkey, the Asian part, very high up in the mountains, as you can see here. The town is somewhere here, and they built a road going up to the observatory here. Actually, the purple one is the observatory, not the red one. And it's on 39 degrees north and 41 degrees east, which is a bit north of the middle of the eternal high pressure zone, which is around 30 degrees north. But they say there are 260 clear nights per year, which is actually very good. Not as good as Chile, of course, but quite good. Then I gave you an earthquake map that shows that this place is actually the highest probability of earthquakes is going through here, so it's very near to the observatory. But I wish the observatory a long life, despite the hazard of earthquakes. I don't present results yet because I haven't found any in the internet, and these are the sources I used for this presentation. Thanks a lot.